All right, let's dive into one of the most brilliant ideas in all of computer vision. It's an algorithm with a name that's just as clever as its design, YOLO, which stands for You Only Look Once. We're going to break down exactly how this one idea completely changed the game for teaching computers how to see the world in real time.
Just think about it for a second. You can glance at a busy street and boom, you instantly see cars, people, traffic lights. It's totally effortless for us. But for a computer, that same exact task has for a long time been this incredibly slow and really hard problem to solve. So how did we finally bridge that massive gap?
Okay, so here's how we're going to tackle this. First, we'll set the stage with the big computer vision challenge. Then, we'll look at the two main ways people tried to solve it, and that's when we'll get to YOLO's one-glance idea that just changed everything. We'll even check out its family tree, and then, most importantly, we'll talk about why any of this really matters.
So first things first, what exactly is the challenge here? Well, we're not just trying to teach a machine what a dog looks like, we're teaching it to find the dog in a picture, know that it's a dog, and draw a perfect little box right around it. It's a three-part problem: recognize, classify, and locate.
For a long time, this was just a painfully slow process. I mean, the early algorithms had to first propose a bunch of potential regions in an image where an object might be, and then run a separate check on every single one of them. It worked, sure, but it was just so inefficient. Definitely not fast enough for anything happening in the real world.
But wow, look at the speed of progress in just classifying images. It's pretty staggering. Within just a few years, the accuracy went through the roof. And then in 2015, something amazing happened. An algorithm called ResNet actually surpassed human-level performance. It got a 3.6% error rate, which is better than the average human's 5.1%. So we had computers that could tell us what was in an image better than we could. But real-time detection, finding where it is, that was still the big hurdle.
And this brings us to the two main ways you could go about object detection. You can kind of think of it as the difference between, say, a slow, methodical detective versus an instant expert who just gets the whole picture in a flash. So on one side, you've got the detectives, like RCNN. These are two-stage methods. First, they find a few hundred possible spots in the image that might have something interesting. Then, in stage 2, they take a closer look at each one. It's really accurate, but man, is it slow. On the other side, you've got the experts, and this is where YOLO comes in. It's a single-stage process. It treats the whole thing as one big problem to solve all at once. It looks at the entire image and predicts everything, the boxes, the classes, in one shot. The trade-off, at first, may be a tiny bit less accurate, but the payoff was a mind-blowing increase in speed.
So let's really get into YOLO's big idea. The core concept that just completely reframed the problem and finally made real-time object detection possible.
The whole secret is right there in the name. You only look once. It's what we call a unified model. There isn't some complicated multi-step pipeline. The entire image goes in one end of a single neural network, and out the other end comes everything you need: what the objects are, where they are, and how sure the model is about its predictions. One and done.
Okay, so how on earth does it do that? Well, the genius starts with something really simple. YOLO takes the image and just overlays a grid on top of it, say a 13 by 13 grid. And this simple grid, this is the key to the whole entire thing. Now, every single cell in this grid gets a job. It has to ask itself one simple question: is the center point of an object inside my little box? And if the answer is yes, then that grid cell, and only that one, becomes responsible for predicting that object. It spits out some possible bounding boxes and the chances of it being a car or a person or a dog or whatever else it knows.
Let's make this real. Look at the example on the left. That grid cell is just looking at some trees and road, so its objectness score is basically 0, nothing to see here. But on the right, the center of that car falls right inside that grid cell, so its objectness score flips to 1, and it immediately outputs the coordinates for a bounding box around the car and says, hey, I'm pretty sure this is a car.
And here's the magic. When every single cell in that grid does its job at the exact same time, you end up with a whole mess of potential boxes. The algorithm then does a quick cleanup step to get rid of the duplicates and the low-confidence guesses, and what you're left with are these nice, clean, final detections. All of this happening in a single pass. It is just so elegant.
But of course, the story didn't end there. The original YOLO was an absolute breakthrough, but the creators and the whole community basically said, okay, that's awesome, now how do we make it even better, faster, and stronger?
Just look in at the first two versions. You can see this really clear evolution. YOLO version 1 introduced the core idea. Then version 2 came along and refined it. They added some crucial improvements like batch normalization to make it train faster, and this clever idea called anchor boxes, which are like predefined box shapes that really helped it get much better at finding objects of all different shapes and sizes. The result? A model that wasn't just faster, but way more accurate too.
And you can see that improvement right here in the numbers. We use a metric called MAP to measure accuracy. YOLO V1 came in at a pretty good 63.4, but look at YOLO V2. It jumped all the way up to 78.6. I mean, that's not a small bump. That's a massive leap forward. It proved that this whole single-shot idea could be both incredibly fast and super accurate.
So why was this such a big deal? I mean, it's fast, it's cool tech, but why does YOLO's unique approach matter so much in the real world?
Well, YOLO has some real superpowers. That incredible speed unlocked the door for genuine real-time applications, stuff like self-driving cars or analyzing live video feeds. And because it sees the whole image at once, it has global context, which means it's way less likely to get fooled by a weird patch of background. And get this, it also generalizes really well. You can train it on real photos, and it can still do a surprisingly good job recognizing objects in, say, paintings or drawings.
The researchers who created it summed it up perfectly. They said, YOLO can classify and perform bounding box regression at the same time. The class label containing objects, their location can be predicted in one glance. That right there, that's it. That is the whole innovation. It wasn't just an improvement, it was a total rethinking of how to solve the problem.
Now, it wasn't perfect, of course. That grid system can sometimes be a limitation. It means YOLO can struggle a bit with really dense clusters of small objects, like a flock of birds, because a bunch of them might fall into the same grid cell. And it could have a tough time with objects that have really weird shapes it wasn't trained on. But hey, these were known challenges, and later versions have kept getting better and better at tackling them.
So YOLO was this massive leap that gave machines the power to see and understand our world at our speed. And it makes you think. We've already built AIs that can classify images more accurately than a human. What happens when our real-time detection systems don't just match us, but start to see the world in ways that we simply can't? It's a pretty fascinating question to chew on.